In this video, we're going to look at a technique for using the information schema in Snowflake to make jobs more scalable and flexible. Even though the use case may not meet your needs, I think you'll agree that the process can be useful in many situations. As an instructor, I have to set up student environments before class and break those environments down after class. Note in Snowflake that I currently have 3 users, none of which are students. I also have no student roles. Furthermore, my training database has no student schemas. In Matillion, we're in the job Create Users Roles and Tables. I'll run the job, and as it's running, I'll describe what it's doing. The purpose of this job is to create users, roles, schemas, tables, and more in Snowflake. Note that the SQL creates roles and corresponding users, grants database and warehouse usage, creates schemas, and further down the list are other activities such as granting schema rights, cloning tables, and creating file formats. To create environments for each student, I run a fixed iterator over a SQL component that contains the SQL we just reviewed. The fixed iterator uses the variable user number to iterate through the provided values. If you look more closely at the SQL, you'll note that the user number is being used to create users, roles, and schemas. Now, back in Snowflake, I'll note that I have 20 new roles, 20 new users, and 2 schemas for each user. Next, let's use Snowflake's information schema to facilitate our teardown process. Back in Matillion, we'll take a look at the job Delete Schemas, Users, Roles. Originally, I had this job set up similarly to the Create Users, Roles, and Tables job we just looked at. I was using a fixed iterator to run SQL scripts to tear down student environments. Let's check out a different approach. If I right-click on the canvas, I'll note under Manage Grid Variables a single variable, Active Users. This variable has a column named Active Users Column with no default values. The Query Result to Grid component is set to Advanced mode, which will allow us to write SQL. My SQL query uses regex to return numbers such as 01, 02, and so forth. I'll bump the limit up to 20 and click Sample. You'll see each of our student numbers based on the schemas in Snowflake. Most importantly, note that I'm querying the information schema to retrieve these values. The Query Result to Grid component passes these values to the grid variable Active Users and maps them to the Active Users column. Student number is the column alias that was defined in the SQL query in the Query Result to Grid component. I'm going to let the job run as I talk through the rest of the pipeline. The values in the grid variable are loaded into the grid iterator, which maps them to an environment variable named user number. And user number is used in the underlying SQL to identify all our objects in Snowflake like schemas, users, and roles. The advantage to this approach is that I always match what's in the underlying Snowflake environment, and I don't have to make manual changes in fixed variables to account for differing numbers of students. If I check out the underlying Snowflake environment, I'll see that schemas, roles, and users are now back down to the original numbers. There are several ways this type of process can be applied to enterprise environments. You might deploy or tear down development environments based on what actually exists. You could migrate table structures across multiple product databases by discovering them dynamically. Or you could run data quality checks across all client schemas dynamically. Whatever you choose, remember that the information schema can make your static jobs dynamic.